All right, we're looking at notes 3-3. So looking through these, the power of a power. Today, we're going to kind of figure out naturally how these rules come about. So with the first one, we kind of look at this as power. So if we remember in the very beginning with our nodes, when we have any sort of exponent, we have, say, 5 to the 4th power. That's the same thing as 5 multiplied 4 times. So that little 4 at the top says how many times to multiply it by. So when we look at this first example, what they did was they stamped it out 5 times. So 1, 2, 3, 4, 5 with multiplying through it. And if we remember back from our notes with power of a product of power, multiplying them, and at this point in time you should have your blue sheet in front of you, your blue formula card. If you don't, then get that out right now. Pause this video. So it says whenever I'm looking at multiplying, if I have something like a to the m, a to the n, then I'm going to take and add those exponents. So then I added 3 5 times. 1, 2, 3, 4, 5. So then if I go into my calculator and I do 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3, I'm going to get x to the 15th. I'm pretty sure there's a faster way we can do that, but let's just see if we can try this one more time. Okay, so the weird thing about this is everything has to be stamped out. So I've got to take the whole thing out. So this would be g to the 4th, 1, 2, 3 times. So I have 3 times of this. Well, then I want to make sure that I'm keeping this all together. So then I've got 2 times 2 times 2, and then just change color of it. We have g to the 4 plus 4 plus 4. So then if I do my calculator 2 times 2 times 2, I get 8. And then if I do 4 plus 4 plus 4, I get 12. So I have g to the 12th. Now mind you, I'm not doing this all. I'm doing this on my calculator. I'm not just coming out of my head on this. I'm using my calculator and I'm typing it in. Okay, so I want you to look at these two exponents versus this number. What do you notice? I hope what you said was the fact that 3 times 4 gives you 12. And that's actually the rule that we come up with, is that anytime we take what we call power of power, so if I have the parentheses and an exponent sitting outside it, then that means that that's got to be there as well. Now the weird part is your number has to get it too. So 2 to the 3rd power is the same thing as 8. And since you have your blue formula card in front of you, you can see on your blue formula card, power of a power, where when I see the exponent raised to another power, then here when it's smushed together like that, it's telling you to multiply. So when I see an exponent outside with parentheses, then I'm going to do multiplication. Multiplication. All right, so let's keep trying this. So if I see here, I'm noticing again that I've got the parentheses and I've got an exponent right outside that. So then what I would do instead is, because of my formula card, it's telling me to do 2 times 4, which is how we got the x to the 8th power. Okay, so let's try again. Ooh, a little bit of odds. So the weird thing that happens with this power of a power is that everything gets multiplied through. So just like whenever we have a parentheses and 2 and I've got to distribute it out, the same thing's going to happen here, except it's going to be with my exponents. So I'm going to have 2 to the 2nd power times a to the 2/3 times 2 power. So then in my calculator, I'm going to do 2 to the 2nd power and get 4. And then I'm also going to do 2/3 times 2. I'm going to do that in my calculator to make sure that I get that right. But it should give me a to the 4/3 power. And that's what it's equal to. So the big thing here is to see how that exponent of 2 went to both of them. It's got to be to both. All right. So then, if I look down here, this one's got it twice, so I've got to do it twice. So here, I've got f to the 4th raised to the 2nd power and f to the 2nd raised to the 3rd power. So then I have there 2 and 4 multiplied, 3 and 2 multiplied, and that gives me 8 and 6. So kind of a little bit of a misstep here for it, but let's take and let's kind of draw an in-between step, because this would be f to the 8th and f to the 6th, which is then why they took and added those two together, because it's showing me that it's multiplication, so I added those exponents together, and that's how we got the 14. On number 6, you always have to look for that little exponent that's sitting outside the parentheses. So if there's nothing outside it, then it's got to happen first before I can do anything else. So again, everything distributing out that -5 to both of them. And then I'm also going to keep separating it number by number, letter by letter. So I'm going to go ahead and add in, when I go to rewrite this, I'm going to have 4, and I'm going to have t to the 2nd power that are already written in, and kind of separate those out so I can see them. And then I'm going to have that multiplied by -2 to the -5th power. And I'm going to have t to the 3rd multiplied by -5. Again, I'm just using my formula card, and I'm making sure that I'm separating these out because I want to look at it number by number, letter by letter. Okay, so then the weird thing is with negatives is you've got to make sure that you're putting that part in parentheses when you put it in your calculator. So when I put that in my calculator, I'm going to make sure that I put that -2 in parentheses when I go to type it in. So I'm going to type in just that part with that -2 in parentheses, raising it to the 5th power. Make sure that you're using the little sign that looks like that, the caret symbol on your calculator. And it's going to give me a crazy decimal, so I'm going to turn that into a fraction, and it gets me 1 over -32. So I have 4 times 1 over -32. I'm going to multiply that times 4, and it gives me a -1/8. Okay, so I've got that all done. I got to go on to my t's. So I know I've got t to the 2nd. It's multiplying with that 2nd t. What is 3 times -5? It gives me a -15. So then if I'm multiplying powers, I'm going to do what with the exponents? I'm going to add the exponents. So I'm adding -15. So then in my calculator, I'm going to do 2 plus -15. And that's going to get me t to the -13 powers. And now remember what happens if I have that negative exponent? It's on my formula card. It drops down below the fraction bar and turns it positive. So my final answer for this is I've got this -1 on top, I've got the 8 down on bottom, and I've got t to the 13th power down on bottom. And that's my final answer. So again, we're making sure that we're distributing out that -5 to both of those numbers. And then after that, I'm moving through my powers. So I had to add them together and drop it because it's negative. All right, number 7. Whew! That one looks like a lot. We're going to make sure we're separating it out so that we can see those different ones. So I'm going to start with my numbers. And again, notice that the distributing symbols are already thrown on there because I got to make sure everything gets that -2. or it gets that positive 2. So then I have negative 3 to the second power times, I got this x to the second power, I'm not going to forget it, x to the second power, and then I got x to the second power times the second power, because I got to make sure I'm distributing that too. And then I've got my y values, y to the negative second right there, and then y to the third power times 2, because of that multiplying out. And then I've got z to the 0 power, and z to the, ooh, there's no exponent there. What happens if I don't have an exponent? Hopefully you just said that it's really a 1. So this is 1 times 2. Okay, so we're going to work through each and every one. Again, I'm making sure that I put parentheses around that negative 3. So that's negative 3 to the second power, which gives me positive 9. And then I'm done with that. That's it. Okay, so then I'm going to move on to the x's. I have x to the second power, and then that, what's 2 times 2? 4. And I'm taking, and if those are multiplying, I'm going to add the exponents, which would be 2 plus 4 is 6. And that's positive, so it's going to stay on top of that fraction bar, just to make sure I'm keeping track of that. Okay, and then my y's, got the negative 2, and 2 times 3 is 6. And then when I go to put that with that negative 2, what operation is going to happen with the exponents? Addition. So I have plus 6. So then I'm going to add those two together. Negative 2 plus 6 gives me a positive 4, which is going to stay on top of the fraction bar. And my last one, ooh, it's got a 0. So that's, anytime it's a 0 power, what does it actually equal to? This one's hard to remember, but it's basically only equal to a 1. So it just disappears, the same way that we have that ninja 1 that disappears when there's in front of x. So if I could write the 1x, or the ninja 1 can just disappear and it can just be x, the same thing kind of goes with this, except this is a really fancy ninja. It's gone to a 1 and it's just gone. So then I just have 2 times 1, and I get z to the second power. So I'm going to pull all of that together. 9x to the 6th power, y to the 4th power, z to the 2nd power. Whew! That's all done. The key here is to do it number by number, letter by letter. Break it down into those 4 different types as you work through it. Makes it a whole lot easier. Okay, we're going to do the same thing here. I'm going to even change colors this time to make it easier. So first things first, I'm going to make sure I'm distributing that each time. So I got 3 to the 3rd power, and then I got this 3 down on bottom. Okay, and then let's keep going with that. Let's just focus only on the numbers. So 3 to the 3rd power is 27, and then 27 divided by 3 will give me 9, and then that's done, and it sits on top of the fraction bar. Okay, then let's go and look at the a's. I got a to the negative 2 power times 3 over a, ooh, how many a's are there? 1. Okay, so then let's even break this down further. So then that would be a to the negative 6 over a to the 1st power. And then quotient, that one's dividing. So when I divide powers, what do I do to the exponents? My formula card says that I'm going to subtract. So that's going to be a to the negative 6 minus 1 power. And the negative 6 minus 1 gives me negative 7, which is going to drop below the fraction bar and turn positive. Okay, so A's are completely done. So then I'm going to go on to my B's. I've got B to the third power, because that 3x when it comes through, over B to the 1/2 power. If they're dividing powers, what do I do to the exponents? Subtract. So this is 3 minus 1/2. So I'm going to type that in my calculator because I don't want to get it wrong. And that's going to give me B to the 5/2 power. We're just going to sit on top of the fraction bar. Okay, so I've got all my stuff here. I've got my 9 that sits on top. That A to the 7th, because it's negative, drops down to the bottom. And B to the 5/2 power stays on top. So I'm going to wait till all the way through each time, letter by letter, number by number. Okay, last one. Volume of a cube that has a side length, S, of 3x to the third power. So when they find the volume of the cube, it kind of can still think about it as length times width times height. But the weird thing is they're all sides. So it's side times side times side, which is the same thing as side to the third power. So if I plug in what I have for my side, 3x to the third power, then I just have to raise that to the third power and simplify it. So again, that little exponent's going to go to both of them. So I have 3 to the third power and x to the third power times 3, because that power of power says that I got to multiply. Okay, so let's simplify that out. 3 to the third power would give me 27. X to 3 times 3 is going to give me 9, and then it's done. That's it. Okay, so just to recap, we're dealing with power of a power today. It has to happen before you can separate things out. Make sure that when you're looking for the parentheses and that exponent to be right next to it, make sure that you're distributing it out so that everything gets that exponent. Everything inside it gets the exponent. And then after that, it's multiply 3. So make sure you're using your formula card. Okay, so at this time, you're working on assignment 2, 3, and we'll see you for notes 3, 4.